Hello, I'm Alejandro. I'm a member of Infineon's Radar and Sensors team. In this video, I will be your guide as we take the first steps in exploring the Xensif VGT60TR13C radar demo board. Join me as we explore the features of this powerful technology and discover the potential it holds for your next project. The Xensif VGT60TR13C radar demo board is powered by state-of-the-art FMCW radar technology that operates in the 60 GHz ISM band. The name 13 refers to the innovative design of this chip, which features one transmitter and 3 receivers in a compact package. With integrated antennas, this chip is very small and offers a great solution for customers looking for advanced FMCW radar features and top-of-the-line radar performance. For using this board, you will need a USB cable, USB-A to micro USB, and you will connect it on one side to the computer and the other side to the board. If it's flashing green, then everything is alright and we can go to the next step. The first step we do is to open our browser and search for the Infineon Developer Center launcher. All you need to do now is to click on the download button and select the version that corresponds to your operating system. Just open the file and install it. Once you have the launcher, you go to Manage Tools and you search for Radar Fusion UI and click on the Install button. Alternatively, if you are a developer, you can also download the Radar Development Kit, or RDK, to access raw data from the radar to C, Python, or MATLAB. This includes access to state-of-the-art algorithms that make it easy to analyze and manipulate the data to suit your specific application requirements. Once Radar Fusion UI is installed, make sure your Xensif VGT60TR13C demo is connected to your computer and launch it. Radar Fusion UI will start showing the real-time data coming from the Xensif VGT60TR13C radar demo board. FMCW radar stands for Frequency Modulated Continuous Wave, and it refers to a type of radar that involves the continuous transmission and reception of a signal with varying frequency. For VGT60TR13C, we have 3 receiver antennas, and we see the signals coming from them displayed here in 3 different colors, and can be enabled or disabled by clicking on these squares. Below, on the left side, we can see the range spectrum that is obtained after evaluating the range FFT. By moving back and forth an object, we can see it displayed as magnitude. Depending on the size and internal structure of the target, this magnitude will stand out more or less from the background noise. On the right side, we have the range Doppler tab. If we move both hands like this towards the device, we can clearly distinguish both targets in the range Doppler plot. Both targets are shown separately, because one hand is approaching and has positive radial velocity and the other one is departing, showing negative radial velocity. Finally, we can also see the signal strength and range of each target. In addition to raw data plotting, we also provide 3 radar applications that can be used for different purposes. The first application is presence sensing, and after applying, it runs an algorithm and predefined radar settings to detect if a human target is present within a defined range. The sensitivity level can be adjusted to suit your needs. The lowest sensitivity level may require the person to move in front of the radar to be detected. However, if you select the maximum sensitivity level, even static persons can be detected, making it a highly versatile tool for various use cases. So now it's not detecting anyone, but when I go in front of the sensor, it will detect me, so it will change to present. And then if we go out of the radar, it will change to absent. In this mode, you can also check the presence sensing for the range. So you can check the range of the target in front of the radar. Our second application is range and angle measurements, which utilizes our radar as a motion detector to show the range and the angle of the closest moving target. Take care to orientate the radar as shown in picture. While this application is running, you won't be able to change any other settings, but you will be able to see which configuration is applied and monitor the range and angle of the closest moving object with ease. The third and last application is segmentation and seamless tracking for multiple targets. In this mode, you can configure the orientation and bandwidth of the radar. You can stay in the ISM bandwidth or exceed it to 1 GHz in order to achieve a better range resolution. It's important to orientate the radar as indicated in the picture for optimal performance. While the segment size, field of view and radar signals are fixed, you can view the settings that are applied for this particular mode. The most important plot, located on the top right hand side, shows the detected tracks and highlighted segments from the user's perspective. These segments are divided into 20 degrees increments, ranging from -60 to 60 degrees. We hope you found our extensive VGT60 TR13C radar demo getting started video helpful. If you have any questions or comments, please feel free to leave them below or join the discussion in our Infineon radar community. Links to these resources are provided below for your convenience. To learn more about our product and its capabilities, please visit our website. Thanks for watching, and we hope to hear from you soon. Goodbye.